how does this trace route actually work? Trace route is nothing but a ping or the enhanced version of ping. Ping can give you the information from source to destination. Trace route gives you from all the hops, all the routers. So what happens? There is a source, there is a destination. First of all, the source sends a packet with time to live as 1. You know, time to live, IPv4 and IPv6, it is called as hop time. So the time to live is the largest amount of time the packet will live until it is discarded. Okay. So TTL equals to 1. What does it mean? When this packet is sent, the first router is encountered. For example, if I write C:/tracert and I write some www.apk.io, or I can also write the IP address here. Okay. So what will happen when we do tracert? The first thing a packet will be sent with a TTL as 1. And you know, at every router, the TTL will be decremented. So the first router, that is the R1 in this case, will decrement the TTL by 1 and the TTL will become 0. And as you know, when the TTL becomes 0, the packet will be discarded. Once the packet will be discarded or dropped, the router will send an ICMP TTL exceeded message. That is that the TTL has become 0. Now you will get a ICMP reply, and that ICMP reply will tell you what is the time from which IP this ICMP has come back. Okay. That means the destination IP address for the ICMP message equals the source IP address of the discarded packet. Okay. So this actually works as a ping for the first router. You can say like that. First router it encounters. Essentially, the first router will be your gateway only, gateway or the network address of your network. Okay. So the source receives the ICMP TTL exceeded message and adds the router IP to the traceroute hops table, which you see on the left top. Then the process will start again with TTL2. Now it will go to R1, it will be decremented, but it will go to R2, it will be decremented again. Now again the TTL will become 0. So the packet will be discarded. When the packet will be discarded because of ICMP TTL exceeded, this again will instigate a ICMP reply, and now you will get the reply from the router 2. So 3 packets we have sent, that will come back from the IP which is 10.140.126.62, in this case R2. Okay. So now we know the round trip time from R1. Now we know the round trip time from R2. Because the TTL was 1, then it became 2, and then what will happen? TTL will become 3, 4, n like this. So let me just tell you one thing. For R1, it was 2, 1 and 1. That is 3 packets sent, 3 packets received. But at R2, you see the time has increased to 169, 240 and 197. That means that the second router is far away from the R1. Okay. So the packet is routed through the first router. It also decrements the packet value, and it will keep on like this. TTL3 from R3 it will come back. TTL4 it will come from R4 like this. And ultimately it will reach the destination. So all these 1, 2, 3 serial number which you see are the number of hops. These next 3 columns are the round trip time for the 3 packets sent to each in between router, where the packet will be discarded because of the TTL, and the IP address in the last column. Okay. So this will go on. It will continue like this by incrementing TTL by 1 until it will reach the destination. Say TTL equals 11, and that will go to the destination. That is what the destination will give you. So the 3 packets, round trip time and the IP address will be seen. This is how traceroute work, using the TTL of the header of IP packets. Okay. Here you can find out where is the problem, because the round trip time will tell you where exactly the problem is.